This series of videos is on the topic of complex sorting. It's one of the most challenging topics that we teach in this class. So you'll want to turn on the extra brain power to see if you can get it in the first pass or the second pass. Sorting, we've seen so far, has been pretty straightforward. If we want to sort any list or other container, we can do it quite easily. We simply pass the container to sorted and we see the result. Here we have a list of integers, and you can see that when it passed through sorted, it returns another list, and those items have been sorted numerically. If we use a list of strings, and I don't need to change these variable names, but I'm going to. If I have a list of strings and I sort those, as you can see, they sort alphabetically, or something pretty close to alphabetically, which we'll talk about. But more or less, it's alphabetic if it's strings, and if it's integers, they're sorted numerically. Now, first thing I want you to think about is what sorted has to do in order to perform the sort. Sorted performs a sort by checking the type and then sorting appropriate to that type. Now the type is only going to be numbers or strings. There may be other objects that sort in novel ways, but we're just going to look at numbers and strings. And it should be pretty clear that Python, when the sorted function needs to look at how to sort, it needs to think about what it is sorting. It needs to consider each item and ask whether that item should be sorted numerically or alphabetically. Actually, these days, it wasn't true in Python 2, but these days, I don't believe you can sort. Actually, let me do that with this integer here. I don't believe you can sort mixed types. When you try to sort an integer with a string, it's going to say that it can't do it. And actually, if you look closely at the error message, less than not supported between instances of int and str. That should give you a clue as to what sorted is doing. Sorted needs to compare each item in order to decide how that item should be sorted in relationship to the others. So since you can't compare an integer and a string as values, sorted won't allow you to, and you have to have types that are the same as one another. So let's review. When we sort a list or a set or a tuple, we're going to get back a list. And by the way, we could make this a set just to show that that's the case. No matter what we're sorting, we're going to get back a list. And as you can see, y as a set, and it comes out as a list. When we sort, Python, and that is specifically the sorted function, needs to decide how to sort. That's always going to be the case. Sorted needs to know how to sort. And that's something that I want to bring up as a theme so that you understand. Sorted needs to know how to sort. It does it by default by looking at the type. Now, when we're sorting dictionaries, it's the same sort of thing is going on. But what's different about it is that dictionaries offer a different part of itself, or only a portion of it, to be sorted. When we sort a dictionary, we're sorting the keys. Now, I could put these maybe out of order just to show that Python's changing the order. I mistakenly put them in a regular order. But if we sort them, as you can see, they're sorting properly by string value. And what we're getting back are the keys. Now, what we learned last week was that there's a way to modify this sort so that it takes place, so that it sorts the values, or rather sorts the keys, but sorts them by value. And we use that, we use this idiom, key equals dictionary.get. Get is a method of the dictionary. We're not calling get. but we are using get in order to get this sort to happen. Now, the thing to ask right now is, how is this working? What is the mechanism by which sorted is being informed on how to sort? Sorted is still doing its work. It's still sorting the keys from the dictionary. But when we put in a key equals argument, sorted is told to do something differently. Sorted is told to sort these keys by value. Now, we're going to explore exactly how that works, because what we're going to learn in this session, what is called complex sorting, is our ability to change the way sorted does its work. Complex sorting is our ability to change the way sorted does its work. We're going to do that through the use of functions and methods, and we're going to explore that step by step. Because this is a complex topic, I've divided it up into separate videos that will gradually bring us to the point of understanding exactly how we can influence a sort. We're not going to do any sorting. We're going to influence or change the way sorted does its work.